guest speaker is someone who claims that he was born in Security Operations Center as L1 Analyst. He is none other than Archan Choudhury. He is an astute cybersecurity practitioner with more than 7 years of experience across multiple domains and areas of defense cybersecurity. He has played several roles in cyber security operations in the capacity of an analyst, in engineering, in hunting, incident responses, digital forensics, malware analysis, across various flavors of industry, consumer goods, FMGC, media, core IT, cloud product, and so on. He is here with us to speak on the topic doing DFIR on cloud. So, yeah, the stage is all yours, Mr. Yeah.
So I hope I am visible and audible.
Yes, both.
Awesome.
Loud and clear.
Thank you so much.
So
yeah.
Yeah.
So today is anyway Saturday, so I'm in Saturday mood, and I was hearing Nitin's awesome presentation talking about DFIR, and threat intelligence. So probably we can take it as a continued level. So let me share my screen. One second. Okay, I'll go to the presentation mode for my slide. Okay, so if just someone can confirm it is visible, my slides are visible. So me? Because I'm sharing the screen because this screen will not be visible. So I just need a confirmation that while I'm sharing, it's visible. So it will be really helpful. Okay, so I think it is visible. So let me start. Okay, so the topic that brings me here today is like doing DFIR on cloud, and obviously DFIR is the battleground, like from on-premise, maybe in cloud, and whatever may be, right? So let me take us everyone to back school. So because we may be thinking like the protection and detection is everything is dependent on that what you cannot protect because you might not be seeing it, right? But in cloud this conception is like totally different. Okay, so basically you cannot protect what you do not understand. Okay, so now cloud is a conception which is really awesome if you understand it better, but it could give you miserable nightmares if it is not properly, you cannot understand its concept and you cannot utilize its concept properly to doing DFIR, right? Okay, so here comes the brief index. So I'll go through like top 5 cloud security mistakes that we do gradually, and I'll start off with little bit of jokes because might be a little bit useful to help you to understand what the hell is going on. And there may be a real attack scenario. Okay, so this attack is I have like segregated from a real time scenario, and it could be a part of it. Okay, then I'll take you through the logging of AWS, what is very much important, and how probably you can set up the configuration what is required, okay, for doing an importance and AWS in incident response. Okay, and the attack scenario that I'm going to explain. So I'm going to explain the investigation flow if the same attack scenario happens to your platform, how we investigated and how you can leverage that investigation flow. So in the meanwhile, I'll discuss about the third party tools and vendors, what we have discussed. And I'd like to show you a little bit of automation demo, how you can get through all of these things through an automation platform. Okay, so I have prepared a quick video for it because time is less, so we want to cover so much of thing. And last thing, obviously, Q&A. So about me, I think you have already got the explanation, but I just want to make why me, because why you want to listen from me like that. So yeah, I was born in SOC and still I am in SOC, probably like 7 years of experience, and I'm working as cloud like DFIR SME in Informatica. And probably I am like I was in part of developing the AWS cloud security SOC as a service, that catalog and that line, and doing threat hunt, threat intelligence daily to daily life of my job role. And if there is any incident happens, I join every bridge and I help incident doing that investigation flow and every damn thing. Okay, and I love forensics, and you can follow me everywhere, so that I'll coming up from where you can follow me, right? Okay, so coming directly straight to the point. So 5 cloud security mistake. So by seeing this image, I get you are getting something, right? So the main thing is that misunderstanding of the concept, right? Because many time we think that if we are adopting the cloud, then we are safe, but that is not the case, right? So cloud, securing cloud is your responsibility. That the most important thing that you need to understand, and that is the most innovative way of the AWS shared architecture model, shared security model. Okay, so this is the first mistake. Second one is we miserably fail these like update cycles. Okay, because we think that, again, this is coming up from the first mistake. We think that, okay, I have put everything in my cloud, so maybe I am safe, I don't need to take care of any updates, I don't need to take care of anything. But that is wrong. So your patch cycle, your patch management stays as far as like important whenever you are doing it on prem or in cloud. So cloud is very important because you have to understand the concept. Okay, so that is the second mistake. Third one, so it's all about like assuming it is secure. So it will be like if you are doing cloud properly and probably you are dumping the data here and there, and you even don't know what the hell is going on which state you are dropping the cloud storage, you are dropping your instances. So instances mean EC2 instances. That is obviously the thing we talk about very seriously. Okay, and obviously, so the lambda functions. Okay, so Azure functions, lambda functions, if everything. Okay, I guess a message.
Mr. Arjun, I think
Yes,
slides are not up. Your slides.
is it not up?
No.
Oh, oops, sorry, let me share again. Okay, 1 second. Sorry for that. Second.
Yes.
Okay, I'll start from the current slide. Okay, now is it visible?
Sure. Yes, it is.
Okay, thank you. Thanks, Umi. I messed up. Okay.
No.
Okay, yeah. So I was talking about this mistake, right? So it could be like like you have put everything on cloud and you don't know what the hell is happening. Okay, so probably cloud service, maybe your lambda function, you could have opened it to the internet and you don't know. Okay, so that is the mistake that you are prone to take. So I have explained about this one also, and maybe this one. Yeah, so I think this is the fourth one. So the mistake is like keeping everything together. Okay, so your job of doing incident response makes your life hell trouble if you do not segregate your scope of work. Okay, so maybe you are doing your management node in probably one account, you are putting your storage in one account, you are doing everything probably in single account, and you are putting every damn thing in a single scope of work. Okay, so that makes your life most miserable. Okay, so that is another mistake. And the last thing, obviously, you need to understand like what are the things is required for your auditing. Now if you have an incident and your like FBI team comes and knock your door, hey, give me that log, and you don't even capturing that log. Okay, so obviously you have to be prepared if any incident comes into your way, and you need to work on that process, right? So yeah, auditing very much important. Now that brings to the scenario, so don't think to shut down the button wherever, like when there is an already an incident happened. Okay, so try from that angle that you are prepared and do the investigation and do the follow-ups like that way. Okay, now the practical scenario, what exactly we are dealing with today. Okay, because it is not on premise, you might not be seeing everything like as malware. Okay, like, and the use case is totally different here. Okay, so you can see probably this is the GitHub logo, so probably this is the open internet. Okay, because in cloud it works so smooth, so lightning fast speed, everything is CI/CD operation. You dump the code in GitHub, you take the code from there, and probably someday maybe your analyst or someone made a private repository from your internal repository and hosted a API key online. Okay, so that might be your infrastructure API key, and might be it is a mistake. It could be an honest mistake. It can, anybody can do that, and you have posted in open internet. Okay, so the next thing, attacker comes, because already right, attacker is already like maybe 2 or 3 steps further than us. So they are obviously scanning every damn thing whatever there in the internet. Okay, so obviously they get hold of your API key, and if the API key is like, they know about the API key, so they already know about your infrastructure, right? Because in some way or another you might be hosting your whole code in public open repository. That might be a mistake for you. You might have done the mistake, you could have done the repository private, that is the most important thing, but unfortunately you have opened it for public. So when attacker get access to that particular API key, so they are already inside your network. Okay, so that could be the private key is like responsible for managing one of your instance down the line, maybe in cloud. So if attacker holds that key, they are already inside the network. So what they can do, utilizing that API key, that we will actually see how our investigation works and how actually we have done the investigation. So attacker is very easy. If your instance is inside your same VPC, that is virtual private cloud, and you have opened some of the like firewall rules, that could be your security groups, we call it in AWS. So maybe your instance might be talking to each other, right? So attacker gives an open space to lateral movement, right? So from one instance they are moving to another instance, from another instance they are moving to the third instance. Okay, and what they are also capable of doing, if your that API key is having some kind of IAM privilege, they can spawn that particular API key and they can open up their own, like multiple EC2 instance. At the end they can take your data. So that's the attacker infra which is sitting maybe far away from your network, and at the end they are taking all of your data, maybe from your S3 bucket, maybe from your instance itself. Maybe you are hosting some kind of Kubernetes service on your instance, and like your application data is important for you and they are taking it away. Now in this whole infrastructure, when SOC comes into picture, so my previous like a speaker has told you about guard duty, right? So whenever a attack happens and this kind of like communication happens, so if you are prepared to do the investigation, so there is an alarm that gets into the SOC. So that's the picture when we are coming into play. So probably you can detect the scenario of like the previous steps as well, but actually actioning a bit late. Okay, so yeah, that's how it works in SOC. So things got piled up and you have got an alert that okay, someone is doing something bad, and you are getting C2 IP address and probably attacker network is communicating. So now in cloud, what you can do, you can do some kind of automation, and it's a like single click solution. Okay, so what you do the investigation and you take first of all the compromised instance down. Okay, so I will come to the investigation portion, how actually we have done that. Okay, but it is very easy in cloud to do that. Okay, it is not on premise that in 2 a.m. at night you need to buckle up your seat belt and you need to go to office and you need to pull the cable from your subnet. So you can do everything just sitting on your desktop. So yeah, so first thing, compromised instance gone. Second thing, you identify what could be the attacker zero patience, right? They have got inside your network using that particular API key. You rotate that API key. Rotation means first thing, you got the API key, you deleted the API key, and next thing, you prepared a new API key. So that means your attacker is gone from your network. So this API key is a new API key and attacker has no clue about it. So when it is there and you spinned up your another set of instances which is fresh instance, and attacker has no clue about this instance, and at the end probably you can do some cleanup by removing all those red EC2 instances that might have been spawned by the attacker. Okay, so this is the overall scenario that we are dealing with in cloud. So it is totally different. Okay, so can you relate it? Because my conception is we are talking about an alert. Might be you are talking about an alert at 2 a.m. Your guard duty has thrown you an alert that someone is doing something bad. And are you prepared for it? So if you are prepared, how actually we can respond to it? Okay, so the scenario that I told you is is a proper scenario that can happen to every SOC in cloud. But what is the investigation flow? How you can do that? So let's gather about the requirement first, then I will go through it. So again, repeat after me. AWS in security is my responsibility. Okay, so logging, it's very much critical. Okay, so so there are several steps that might logging is very important, but in cloud, in specifically in AWS, these things that we are going to talk about today is like CloudTrails, CloudWatch events, VPC and S3. Okay, so VPC and S3 and CloudTrail, these are all very beneficial logs. And if FBI comes here knocking to your door, you all should have a way that you can hand over these logs to them. Okay, any federal authority, doesn't matter for that. Okay, so now breaking down those things, what actually things are getting stored in cloud. Okay, so CloudTrail logs your every damn API calls. Okay, so API calls means in AWS, if you spin up an instance, if you create an API key, if you create an S3 bucket, anything that is called as like API call, and CloudTrail logs your every API call. That is very much important for you to have visibility on that API call, and it consists of the region of the cloud, what is the location, what is the IP, agent, everything. Next, CloudWatch. So CloudWatch is the abbreviation of taking CloudTrail log into system performance metrics. Okay, so you can have a real-time performance using your graphs, alarms, everything that we have seen in the previous scenario, right? We have an alert. Okay, but we have done it a different way. But CloudWatch can be leveraged using the CloudTrail logs. Like let's say, on a certain day, your CPU starts working miserably. Your CPU utilization may be 100. Maybe 100%. So that alarm should be there to your SOC, right? So you can leverage CloudWatch for doing that. Next, AWS config, very, very important. Why? Because let's say you have spinned up your AWS like EC2 instance in some configuration level. Now some attacker comes and changes some configuration to it. Might be they have opened some port, maybe they have done some changes on the security group to make that instance public. Everything gets catched in AWS config. So you do a correlation, what was the config was before the attack and after the attack. Very important to have it AWS config. And last thing is S3 bucket, because this is the place where actually you are hosting and probably you can host your data, right? Very important thing. And probably you need to have your bucket level log. That means S3 everything stores as bucket, like we call it as a bucket. You can consider it as a folder on your Windows PC, and the data which is inside that bucket we call is an object. That might be a file inside your folder in your Windows PC. Okay, so you need to have the logging enabled to your bucket level and object level to have it like full visibility in scope. Okay, so now once you have all these data, and probably you are sending all these data to your SIEM platform, maybe you are leveraging Elasticstack, Sumo Logic, Splunk, whatever that may be. Now comes to the security tools in AWS, right? So what the security tools AWS provide by default, by which you can make your DFIR job easy, right? Okay, so the next thing is that very important IAM, Amazon Guard Duty, we already talked about. Config, CloudTrail, we know about them. And Messi, Amazon Messi is the thing that if there is anything like, like sensitive data that is stored in your AWS account and something is going wrong, so basically you can consider it as a DLP solution on your AWS, right? So important thing. And the other security tools, it's I have just named a few because we have used these particular tools for leveraging that incident, what has happened, and I'm going to show you now how actually we have investigated the whole flow and what was our whole flow. So basically what we did, we have used Margarita shotgun. If you are not familiar with it, so Margarita shotgun is a tool by which you can acquire memory sample, you can acquire the volatile data from your EC2 instance remotely. Okay, and Volatility is an open source platform, you can utilize it doing memory forensics. Okay, and AWS IR is quite similar tool. And for our EDR solution that we call as like antivirus or whatever may be that EDR solution, we are using OS query. So this is the symbol of OS query. OS query takes all of your data from your endpoint. Again, it is an open source tool because I am fan of FOSS, so everything is open source. Again, Elastic SIM we are using as like SIM detection, and MISP. It is a threat sharing platform, so you can leverage it to collaborate all of your threat intelligence into one single place. Again, open source, and the fourth logo is already considered about this Margarita shotgun and AWS IR. Okay, so now comes the main part, how actually our investigation occurred during that particular incident. Okay, so I'll go through the graph, and meanwhile I'll try to show you the snapshots how actually we have leveraged that particular incident. So what actually happened when the SOC alarm gets triggered? Because that guard duty has shown us an alert that C2 communication was happening. Okay, so let me pull up that first guard duty screen. Now if you see my screen, so you see unauthorized access EC2 malicious communication was happening from some instance. I had to merge like disable the names because that is confidential data, and account ID as well. But note the instance, because there are so many instances was communicating to some malicious IP, but we don't know what could be that malicious IP. So this was our first trigger to our SOC, something bad is happening. Okay, so we send that particular data to our Elastic SIM. What Elastic SIM basically does, it sends back the data to our alarming system, and it triggers an alarm to our SOC. It sends a email solution. So let me show you what the email solution looks like. Okay, so this is the email that we got from our Elastic SIM. C2 communication happening, and you see there are giving the tactics of MITRE framework, and everything is given like the rules. What is the rules called? So guard duty, you see AWS guard duty, this is called the index of Elastic SIM. Okay, and by seeing that, you already know that something bad is going on, and I have to investigate. I have to go into the investigation mode. Now our automation is some kind of feature, and you can utilize this as well. So when there is an email alert triggers, so we have a webhook configured. Okay, so that particular webhook will do, it will go through our threat intelligence platform, and it will search for the reputation of the IP address. Okay, and if it finds something bad is going on, it will come back and it will say to Elasticsearch to do something else also. Okay, so in that particular case, so let me open up another screen. So yeah. Okay, so this was the virus total. I think everybody is familiar. So this was the IP address. Okay, and when Elastic SIM goes to in the fetch mode to do some analysis on, because everything is happening automatically, we are not doing it. So we have configured our tool in such a way that it can do it automatically. It can come back and say, hey, this IP looks malicious. Okay, because this is the IP that is found from the guard duty log. Okay, so let me show you the guard duty log as well if I have it with my, so I think I have it. I am opening it. Okay, so this was the guard duty log from the alert that we have exported. Okay, now if I want to show you guys just to notice on this portion, EC2 instance, blah 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 is communicating to and disallowed IP address of this one on the list of Australian OC. Maybe this is the like threat intel that we have provided to guard duty, and guard duty has a feature that you can also create your own custom reputation list. Okay, so you save it in S3 and you can do that kind of thing. Okay, so you see the event first came on maybe 14th. Maybe we have missed that alert because it was not so much of higher risk level, and every alert that is coming in high and critical, we are getting it, that is getting flowed to our to our automation flow, not the medium alert. So that could have been a medium alert, so we haven't bothered about it. Now when the last event seen on 16th, it was a high alert. Okay, and you see there are 8 event counts. Okay, so I have shown you the guard duty snapshot. There are multiple alerts flowing into the malicious IP app happening. Okay, so this is the particular IP address that was communicating. And one also thing I would like to show you, that very important. If you go here and if you see the group name, security group name, and there are some other things also available, this network interface. Okay, so this network interface is very much crucial to have you correlate the alerts, because network interface is a thing by which you can consider is as a like firewall interface. Okay, so in your network interface you might have like several public IP address, and your network interface is talking to a bad IP, so you can utilize this particular network interface to correlate your alert to a further level. Okay, so I'll show you how actually we have correlated the alert. But next, now go to our attack flow and investigation flow. So when we have seen something bad is happening, so in Elastic, what actually we did, we need another flow to our West query to search if something is bad happening on our endpoints level. That means our EC2 instance level. Okay, so let me fire up the West query console as well. So this is the snapshot of our demo West query thing that you can consider it as a management node. And you see these are the things, these are the probable host that is we are having. So you can have like thousands of hosts depending on your solution. Okay, so this is the management console on West query. And what actually we did on West query, we ran this particular query. You see, West query, we are trying to identify if there is any socket communication happening from our Docker environment networks to this IP address. We have seen this IP address in guard duty, right? So we tried to identify if West query can give us some hit that hey, your machine is suspicious, your machine is compromised. But unfortunately, what we couldn't identify, we have no hit on West query. Okay, so what else we can do? So we have another workflow when this workflow is coming back to Elastic to search to our whole infrastructure depending on the VPC flow logs. If you remember, we need VPC flow logs also, right? So that consists of everything, right? Every communication living on your network, every network communication, you can consider it as your firewall log. Okay, so we didn't identify anything on West query, so we fire up another query in our Elastic. Hey, if your IP address that we have found from guard duty can give us some indication of flow that your machine is compromised. Okay, so let me pull that snap up. 1 second. Yeah, here we go. You see, this is the same IP address I just pooped, and the destination IP address. And you remember I showed you these interfaces, right? So we are piling up, we are searching these, we are trying to correlate from the logs if we can identify how many machines are talking to the bad malicious IP address. Okay, and you see we have so many of them. You see you have so many of IP address. So that means our multiple machines is now being compromised. So now how actually we go to that point? It's pretty much simple. Okay, so from that angle, we ran another West query to identify, basically targeting those machines which we have identified from this previous Elasticsearch scan, right? And another flow from that particular search to identify on the I can say that what could be the common thing happening in that particular time interval on those all machines which is actually communicating to that bad IP. Okay, so that particular thing gave us one very important thing, and you can see that we have searched as the agent name of this IP, and this IP, and you see all the user ID. So I just want to focus. I just want you to focus on this particular area. You see, these user IDs are same. I have to mask it anyway because it's confidential. But you see, these are the all API key, and also the user is same. And you see has been so much of event that is happening from that particular API key. So now we identify that probably this API key has been behind that particular attack, and it is doing something bad. What next we can do? So once we have identified that particular API key, we have another flow from that. We have to dump any of the machine image, and we need to go to that further analysis level if to identify something is happening bad or not. Similarly, we used our Margarita shotgun and IR sample tool to capture the volatile data of one particular machine, and OS query didn't give us anything. I show you, right, because we identified the API key, right? So that was our main flow, and from this, this is, you can consider is that's EBS volume from compromised instance that we have captured to identify in forensic level if something is bad going on to the particular network. We have ran the particular search, but we didn't identify anything bad happening on the volume level. But you can consider that something obviously going bad on the memory level, right? So that's the reason we could have identified something on volatility search. I will show you that what might be the case happening. But you see, at this point of time, we have run volatility on the like the memory dump or the volatile data that we have captured. Okay, so now next thing, when we have already identified the culprit API key, what we did in the previous slide I have shown you, we have rotated the key. That means we have replaced the key, we have deleted the key, and we have created a new key. And what else we can do? We can search using that particular API key if a new instance has been spawned up. So obviously we can see other instances also spawned up, right? So unfortunately, I do not have that particular snap to show you, but you get my point, right? What actually we are trying to do. Next thing, once we identified all those machines that has been spawned up, we clean them all. So one step done, your cleanup is done. So we have rotated your key, and your cleanup is also done for the compromised instances. Now at this point of time, you know, right, what are your actual compromised instances, not this one, because this one is created by the attacker. You have to clean up all these instances as well. Okay, we have cleaned up all those instances. So that means cleaning up is nothing. You can simply run a script to take down all of your instances, and simultaneously you can spin up your similar instances using Terraform or using any of the script. So if you are working in the production environment, your script will be ready and handy at this point of time. Okay, so next thing, for using that particular key, you can run again Messi, and there are some other tools like open source tool also available. So GitHub by default can give you an awesome tool by which you can scan whole of your repository if you have done similar mistake, and probably you are lucky because attacker hasn't got that particular API key. Okay, so we found that particular repository. You have seen that particular name, right, in the repository. Let me show you again that particular screen if that makes more sense. You see there is an user. Okay, so we identified that user running a simple scan of Active Directory, who is that particular user, and we have identified this particular user has hosted a private repository on his own name, and he have made it public. Unfortunate, right? So we reached out to him, and we have asked him to take down that particular repository. That means our cleanup is done on that level as well, right? So we have now mostly coming to the end of this investigation flow. What we have actually done, and now we have identified something bad is happening on the memory level. Okay, so I have just taken up some snapshot of our volatility screen. Now you see, this is not, I just don't want to make any spoiler, because volatility is a huge thing, but something is going on. The machine was actually I can say legacy system, and as you can see, it was an XP system. So you can identify similar things happening on your production level, right? But you got my point. Something is bad happening. IE Explorer had got one kit, and that probably communicating to your malicious IP address. So from your memory forensics, you can actually identify what bad is happening and what is going on. So this is the full investigation flow. Okay, now you can tell me, hey, there are a lot of things happening at the back end, so everything seems familiar, everything is okay, but how you can automate that particular flow? Is there a way that you can particularly automate that shift, that some portions of it, not everything, that okay, so I don't need to bother anything if something goes wrong, and I don't need to wake up at 2 a.m. and like I can do everything, and probably when I log in at 9 a.m. in the morning, I get the volatility reports. I can get all those report at scan, and probably if I need to do a further forensics, I can have my like a compromised machine in an isolated platform, right? So that is a dream thing. Okay, so I have prepared a quick demo for you guys, so let me fire up that video for you. So okay. Okay, so one second. Let me play this video from a VLC. Okay, there you go. Make it full screen. Okay, so this is our overall I know it hell complex, but don't bother about too much, because just concentrate about the portions that we are going to talk about. Probably this is the compromise system. These two machines is in HA pair. Okay, this is our whole architecture that we are talking about. Okay, and if I go to in the deep down section, so probably this is the thing we just want to achieve. Okay, one guard duty alert came, you can leverage your CloudWatch. So this is the flow of automation, how you can actually achieve it. Okay, so once you have fired your CloudWatch, probably there is an lambda function that is capturing the forensic data, what is happening on that particular machine. You fire up a step function from that particular lambda function, which step function will trigger all the events at your backend. It will send your guard duty findings to your Slack channel. So that means when it fires up something bad, so you know, okay, maybe you are watching some movie and you are doing something, you know something bad is going on, but you don't need to wake up. Okay, so the thing will simply, like send you a message in your Slack channel, something bad is happening. That lambda function will capture the memory, it will check all those steps. So you have codified all those your steps, and once the command state has been done, it will isolate that particular machine. Okay, so isolate means it will probably move the machine from production, and it will create another VPC for you, and it will put that particular isolation machine to another VPC, so that once you log into the morning and you want to run some of your forensic cases, probably that's a better idea for you to do. Okay, so what next? What next? So again, so you see, one second, let me go back a little bit. So yeah, so you see this is our machine that was compromised, and we have isolated the machine. Now target is to move this machine from this availability zone to this availability zone, because this is our, you see, this is a quarantine VPC, this is our incident responder VPC. So we want to move this particular machine to here, and we can start all of our fun stuff here. Okay, so what next? So once the isolation is done, send the isolation notification to our Slack channel, because we need to send all of the things that is happening simultaneously. Okay, again, we capture snapshot. I showed you, right? We captured the full snapshot of the machine to identify the thing. Create forensic instance, that is our evidence collection machine on which we will run actually the volatility. So now I will skip forward. Okay, so this is the whole phase of, like, once you have identified your forensic workstation, what is happening, you attach that particular compromised machine volume, and you come here and you do all those memory stuffs and fun stuffs, then check what of your commands and run memory and all those blah 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 steps. Okay, so now I will show you actually the what the thing actually happening. So probably let's consider this is our lab instance, and what actually we can do, so this, okay, so what the thing, actually both machines are in HAPR, right? So if you just notice here the private IP address, okay, so 43 and 234 both machines are in HAPR. Okay, so these two machines, so we are going to infect one particular machine. So I was logged into that particular box, so lab IR Nginx box, and you see this is 43 machines, and we are having in a situation to take this particular machine down through our automation. Okay, so let's see what we have. So now if you do simple ls, you see I have some scripts obviously into running that particular machine. So what I will do, simple, I will fire up one particular probably DNS exfiltration attack so that my guard duty has some findings. So what basically I did, yes, I did some sudo that particular script. I just run that particular script. And now you see if I come to this guard duty section, it has sent me some alerts. That alert we have seen in production. Okay. Next up, what actually it is going. So we have identified the instances, what is happening. So in that identification, it actually fires up a step function. So this step function, you see, it is particularly currently running state. Now this particular step function is doing all the job that I showed you manually. It is doing everything for you. Okay, now if you see this green section means the work has been done. Okay, so your guard duty findings has been sent, your memory forensics is getting started, and let's see what this flow has to offer. So green means done. So now you see your Slack channel, you are getting that particular guard duty alert that hey, something bad is going on, right? So next thing, you see, so step function is capturing the memory dump, start the isolation of that particular instance. Now if I come here and if I particularly refresh this particular page, so you see 234 is only coming, right? So we do not see that 43 instance is coming here. So that means that 43 instance has been taken down by our automation script. Now see, I am refreshing that particular thing again. So you see another communication coming to our Slack channel that memory dump has been captured and isolation has also been done, and probably we will so obviously come to that particular point and coming to this all section one by one, right? Okay, so now you see here things are coming, so things are getting piled up, and you see now our forensic command is getting run up. Okay, so these are the commands that basically we are running for you, right? So automation script is running all those commands, and you see these things are going one by one, right? Okay, so we run a memory scan, and you see our Slack channel is getting notified. You see both snapshot and memory analysis is completed now. Now let's see what's happened. So we are storing everything in S3 bucket, right? So you see the logs is getting stored in S3 bucket. PS list is getting S3 bucket. PS tree is getting loaded in S3 bucket. So these are the all outcomes of the volatility, right? So volatility will run you everything on the backend and store everything in the S3 bucket. So like the way in the morning you log in and you see everything is already done for you. Okay. So next step, I'll just keep the video for a bit, and now you see memory forensic is done because we have captured the logs and it is already sent to your S3 bucket. Okay. So what's going on now? You see there is another notification sent to our Slack that is auto scaling launch is also fired. So that means a new instance is getting spawned up. So that means the new instance is our HAPR that the machine was actually compromised. And you see, if just we refresh the page, you see there is another instance got spawned up, and you see there is an instance which is now in isolated state, and we have done the memory forensics on it. Now what we can do, we can simply now refresh this page. This was our previous machine, and 43 was our compromised machine, right? So if you just simply refresh this page and you see 242 and 234. So 242, our new machine that has been spawned up from the isolation step, and yeah, so that's already completed our whole automation flow, and that's all. So right, so this is how way you can actually like doing all of your automation stuff. And by the way, if you want this script, so you can take to my GitHub repository. Probably I'll take some time and dump all those stuffs, but yeah, so that's all from my end, and probably you can follow me. I have a channel of Black Pearl, and you can follow me everywhere where I keep showing all those stuffs. And yeah, that's all.
Thank you, Mr. Archan Choudhury, for your presentation. So we have few questions. So,
Yeah.
are there specific protocols to collect evidence, especially volatile data such as remote logging and monitoring data?
Yeah, so it is like there is no as such protocol, but yeah, so it depends on your legal support team, right? So remote login session means, yeah, everything is, if it is something is inside your machine and you want to dump your SSH log, obviously you can do, but it depends on your architecture, what exactly your threat field you are working on, and if your legal team wants that, okay, let's talk about FedRAMP. So FedRAMP is a compliance, and it requires and it needs it, I basically ask you to capture every damn log, so that time you have to capture. But yeah, so it depends on your classification and what your risk example.
Okay, so what are the common evidence preservation methods to protect digital evidence from modification and tampering?
Okay. Yeah. So basically, chain of custody is the main thing that you have to follow. So that means, like, probably you can follow your chain of custody method, and you can dump the data what actually you are going to analyze to a cloud storage like S3 bucket. You can probably store it to a Glacier and encrypt it so that no one can come to it and harm it. And obviously, whatever the steps that you are actually going to take, maybe your forensic step and everything, capture the snapshot of your work, right? So if you have a compromised machine, you want to analyze on it, do a snapshot of it, store the snapshot of the compromised machine to a bucket, encrypt it, and start your analysis on the second snapshot. So yeah, like the way.
Okay. So, investigators usually scan the web browser's history. Is this evidence sufficient to show that the person whose digital evidence was used to access these websites was the owner and or suspected users of the device?
Okay, yeah. So a web browser can be a good thing, but not always. So if we talk about only the on-premise structure, so there are a lot of things that you need to capture from a particular endpoint. It could be your like system event log, security event log, PowerShell log, all everything. Not only limited to your event history, because if your event history could be something the user is doing, but if the
Yeah.
machine is compromised and you are not having a point of your insider threat, so that is making no sense, right? But yeah, if you're talking about on-prem system, it could give you some good of hint that if that is an insider threat and the user is doing something anomaly.
Right, so that brings us to the end of the question and answer session. So, Mr.
Thank
Archon, that
you.
was a nice demonstration on incident response investigation flow. You made a complex process easy to understand and visualize. Thank you for your presentation and wish you to have us with you again in our upcoming events.
Yep, thank you so
Thank
much.
you. Bye.
Bye bye.
Bye.